The ADCPs on this ship, ADCP Acoustic Doppler Current Profiler. Acoustic because it pings, just like shouting into a canyon. So you say, hello, and then the sound, in the case of these instruments, echoes off of plankton poop, gradients in the density, things like that. It reflects and it comes back. And since it was pinged out at a given frequency, if any of that stuff is moving, it'll come back at a different frequency. That's the Doppler part. So like the train, you know, it goes past you and the sound frequency drops. So we ping out at a given frequency along a beam, and if the sound is moving, if the water is moving towards the instrument, then the pitch comes back higher, and if it's moving away, then it comes back lower. And the shipboard ADCP is on the ship, so it's got two beams facing forward, which is that direction. I mean, where we are now, I'm looking backwards, but it's got two beams facing forward, so those two beams come back with positive or higher pitched values, and these two beams come back with lower pitched values. But it has four beams, and so each opposite pair of beams describes a plane, and that plane means that you've got a along the beam velocity here and an along the beam velocity there, and you can decompose that into a horizontal and a vertical. So there's a horizontal and a vertical for each of these pairs, which means you've got two horizontals, and those are in ship coordinates because this thing is bolted to the bottom of the ship. So you have motion past the package that's measured in ship coordinates, which is, from this perspective, it's like looking through a hole in the floorboards of your car. All you know is what's going past you. You are just plain, you're the ADCP, and you're in the front seat of the car looking through the floorboards, and all you see is the water going backwards. So what you need to do to find out what was going on underneath you is to remove the motion of the vehicle that you're in. So if you think about this car analogy again, if you're driving, let's say slowly so that you can measure it, if you're driving slowly over the road and the road doesn't move, then it just goes backwards. If you're driving slowly over the road and there's a sheet of water going across the road, then you'll see, actually, you won't see things going straight backwards, but they'll have a little bit of an angle to them. And so that's what we try to take out. There's the measurement of the ocean relative to the package, and then you orient that into ship coordinates, and the ship is facing north, so you take the heading out, and what you're left with after a lot of linear algebra and some editing is the ocean velocity. So what the difference between the various differences between the shipboard and the lowered ADCP, but one of the differences is that the shipboard ADCP is continually on, and so you acquire data for a while and throw out the bad stuff and average it, and you call that one profile. So for this instrument, I don't know if you can see it, but I'll use these pictures to describe it. For this instrument, which has a frequency of 150 kilohertz, that means that the scattering, the optimal length of thing it would scatter off of would be like about a centimeter. So this picture on the right has meters down this axis from the surface downward, and you can see that the deepest that the colors go are 250 to 350 meters, and it changes a little bit. The depth is not constant. So each one of these things are smoothed out a little bit, but there's one line for every 5 minutes, and it has 8-meter resolution in the vertical. And so this is the ocean current going to the east, and this is the ocean current going to the north. Down here, and I can't make the pictures any bigger, sorry. Down here is a little vector plot of the same thing. So we were south, and we've been going north, and so the color is just the temperature that was measured by the instrument under the ship. So it was cold down here, 18 degrees, not that cold, and really warm here, 21.5. If we look like here at 35 north, south, there's just a little tiny arrow to the east. This is just a surface vector. This little arrow to the east is going to be that little arrow there. That's a little red thing. It's up near the surface. It's a little red one, which means it's positive, and this component is the east component. So here we have west, east, west, east. So there's west, east, as we're working our way north. You can see from these contour plots that these eddies that we're looking at are very, very shallow. They only go to about 75 meters, and they were much bigger even farther south. Evidently, this area off of Australia is an area of intensified upper ocean eddy activity. But you can also see that as we've moved farther north, basically right about here, there's a division. On the left, these things are trapped near the surface, and on the right, there may be a little bit of activity near the surface, but it has more interesting information farther down. So what this means is that what these pictures allow you to do is see what the ocean is doing underneath the ship while you're at sea right now. And that's useful for a variety of reasons. They've used it on this cruise, for instance, when we had some strong currents that were these eddy things. The people who had the trace metal rosette off the stern, if there's a really strong current, that's going to pull, the ship has to orient with respect to the wind and the waves, and also what the package is going to do off the stern. And so if there's a really strong current, that could pull the instrument away, kind of like you're flying a kite. So it's useful for them to know whether there's a strong current near the surface or whether it goes all the way down. A lot of times the base of these currents are going to be places where there are strong gradients in nutrients or strong gradients in density. And so these are very interesting features. For people who want to know about whether you've passed a front or not, a much stronger version of this division here, where we have yellow means east, quite deep, and to the left of it is west flow. That's, there's a division there where you've got a big, long, deep boundary where flow is going one direction on one side and the other direction on the other side. These things are usually correlated with temperature and salinity changes. We're doing 30-minute, half a degree spacing on our stations, and this has about 5 kilometer spacing. So the purpose of this program is not to resolve fine scale features, but this instrument helps you see what the features we're doing at a finer scale than the CTD operations that we're doing now. I mean, other cruises would be out here with instruments that measure things even finer than that, perhaps. This one on the left is updates every 5 minutes and has a tiny little, a single profile. This is the last 5-minute profile with well, for my own reasons, red is the one that would go east-west and blue is the one that would go north-south. I mean, you can't use the same color scales. I just picked 2 different colors so that you could distinguish the 2 lines. So that would be over here, and here's the north-south plot, and you can see that it's positive near the surface. So here's the V that's positive near the surface. And then you can see also in the middle, both of them have blue in the middle part. So this one has a big blue blob. Blue is negative, so they're both showing negative in the middle. So the 5-minute plot gives you a sense of, if you're looking for a feature or something, it's basically a sort of a sanity check on what's going on, and it gives you a better idea of what the structure of the ocean is right now. And last but not least, I mentioned that, well, last but not least in my first sentence, I mentioned that you have all this linear algebra and geometry that takes place, but one of the things that's critical to that is knowing what the heading of the ship is, because you have to know whether that stuff that you saw under the floorboards is actually going west or east or what. This plot down here at the bottom is this wiggly line here, which is around 3 degrees. This is the difference between the gyro, which we use as the primary heading device. Gyros are all over the place, and they're very, very reliable. And usually the bridge uses the gyro as its primary way to steer. So you know that if you're using the gyro for your ADCP, it'll always be there. But it's not very accurate. Gyros can have errors of 10 degrees down in the poles, and they tend to flip out a little bit whenever you stop or start. And so if I were to show you a plot of the heading correction, this is the difference between the gyro and the Ashtec, which is a GPS-based device. If I were to show you this plot for the whole cruise, it would have been more like 5 degrees when we were farther south, and now it's worked its way down to 3, and a lot of times it's a different value when you've stopped compared to when you're going. So you can see it go wiggle, wiggle, and then you stop on station and it's different, and then you go. And so the thing is, every degree of error in this, every degree of error in the gyro is 10 centimeters a second error in the cross-track component. I can draw you pictures if you want. You probably don't. But if you look at this picture up here, all these lovely eddies that we see, here's a 50 centimeter a second scale. Most of these values here are on the order of 20 to 40 centimeters a second. There's one that's 50. Open ocean speeds of 50 centimeters a second are not very common. Usually that's a really big current, like Antarctic Circumpolar Current or Gulf Stream is really big. But in the middle of the open ocean, without a feature, a strong current like the Gulf Stream, it's rare to get something that's over about 50 centimeters a second. So here we have a gyro that's off by 3 degrees, and it's wobbling, which means that you can get, if you had no flow in the ocean at all, and all you did was use the gyro instead of the Aztec, you would have the most amazing and wonderful eddy features that were completely bogus. They came completely from the gyro, just because the gyro has errors. And that's because the ship is going at 500 centimeters a second, and we're looking for values that are around 30. So we're looking for a signal that's 1% of the thing that we're measuring, and that's why it's so critical to get these headings right. So these red dots here, this was an experiment I tried to make sure that my software could extrapolate across a gap, basically. So I unplugged the gyro, and the number of good points fell to 0, and the heading that was used, the correction that was used, stayed, sort of constant. It's been supposed to do that for the last year, but evidently I didn't catch all of the cases, and so there was a bug. But okay, so the other thing about this is that to have all these plots here benefits the people on the ship, but it also benefits the people at home. It benefits people who are going to use the ship later. So for instance, over here on my, yeah, this is, I don't know, you probably can't see this one. Let me bring it up on this screen. Okay? Yep. All right, so what we have are, in our lab, we wrote the acquisition and processing software for the shipboard ADCP, the commercial ones. And this little table here has a list of all of the ships that have this acquisition software on it. So 2 of them were funded for, and that's the 2 polar ones here, the Gould and the Palmer. The rest of them fall into basically 2 categories. One of those categories is I was on the ship. And so if I'm on the ship, I have put this stuff on, and people have liked it. And for one reason or another, either because the scientists wanted it or because it runs on a Linux machine and not a PC. And if the group doesn't like PCs, then they would really like to do something that's not Windows-based. Or because they know that, at least at the moment, if it's our software on there and we know about ADCPs, then we're watching it. And so there are various people who have either requested to have this on their ship, or I was already there and it was easy to put it on. And then there are a few NOAA ships that we have it on because we're interested in the data. And the commercial software does not allow you to use, well, there's a new version of it coming out where they claim that whenever it does come out, that it'll be able to do what we do, but where you use the reliable instrument as the reliable instrument, which is the gyro, as the primary heading, and then you correct it to something else when that's available. They didn't have that choice. You just had one. Put in the gyro, that's it. Or you put in this other thing and that's it. But then you have no comparison and no quality check. You don't know whether it's wigging out or anything. So anyway, what our software also does is so it's got this 5-minute update. It does the 5-minute profiles and it stacks them up, and then every hour it stuffs them into a little database and then does some post-processing on it, which involves more editing and a rotation and some calibration values, and it makes these plots here. But it also puts out a little snippet of data. So for about, I think, something like 20 kilobytes, we send back an email of very digested data, but we send back an email, well, we don't, but the computer does, sends back an email to a user on land, and there's a cron job, a process on land that looks at the emails and then plots it. So the 2 things that are, well, there are various things that I think are exciting about this, but one of them is, for instance, well, let's see, let's go look at the Kilo Moana. So I get an email every day from each one of these ships, and it says, my heading correction was thus and such, which means I did process data and I did have a good heading correction, and I was able to get something, you know, all the pieces. It's like the last domino fell, so you know that all the pieces before that are there. If somebody were going to, I mean, we're in the middle of the Indian Ocean, so it's going to take a while to pull this up. But if somebody were going out on a cruise soon and they wanted to know if their ship was, if the ADCP was working on their ship, they can call me up because I'm looking at the instruments, or they can look at these things themselves. These guys are in shallow water, so we're not going to see anything. We're not going to see anything useful there. Hang on, let's see who else we have. Melville is turned off. Jaime's in port. All the NOAA ships are in port right now, for the most part. Wakoma had a problem with their instrument. They have a cruise next week with a new instrument, and I'll look at that data, see if there's a problem with the, let's see, who else is at sea? I think the Nor is at sea. Most of these ships have had a sort of a dry period over the winter. Let's go see what the Nor gives us. But getting pictures like this, well, getting small amounts of data from the ships in advance allows us to monitor the situation and see whether the instrument has a problem or not. And so if somebody else is going to come in and use it, then they can tell whether you know, there is somebody who's looked at it. In general, if you don't have something like this, a lot of times the techs, you know, they turn it on, but they don't actually have a good quality. You know, they see some colors, but they don't necessarily have a good sense of, they've got so many things that they have to deal with. They don't know fine details of whether there's a problem or not.
So right now these shouldn't be run without a specialist on board to...
No, they're perfectly capable. But the thing is, they're actually quite reliable, most of these instruments, if it's been set up well. So that means that you have your acquisition PC, whether it's our stuff or the commercial stuff, and you have your instrument. If the physical installation of the instrument is good, it's not going to ever cause you any problems. I mean, it'll get biology things growing on it you have to scrape off or whatever every now and then. But for the most part, once the thing is physically installed, it'll just keep going. And once your inputs are installed into the computer, those will just keep going. So so far, we have not run into very many problems where the instrument itself has a problem. But if you didn't set it up right, or what normally happens is that something changes with regard to the inputs. So they swap out gyros and they didn't tell you. Or they make an all-purpose feed of heading to the main lab, because most people are just going to write down, well, we're going, you know, we're going at 310 degrees. They don't really care down to the 0.1 decimal. And so if something like that changes, and on chips you just don't know. So usually it's one of the inputs that changes. All right, here we go. Holy smokes. Which ship is this? Oh gosh, okay, this is the Nor. In meters per second, we have 2 meters per second. They must be 62 west and 38 north. They're crossing the Gulf Stream. They're up near some eddy. These are huge, absolutely huge. 2 meters a second currents, 1.5 meters a second. It's conceivable there's something wrong. What's more likely though is, that they're in a place with very strong currents. And so you get a sense of the strength of the currents and the depth of penetration, whether they've got really bad weather or not. So the one I want to show you that's an indication of a problem, something I'm going to have to deal with when I get home, is this one, the Hi'ialakai, is a NOAA ship that's based out of Honolulu, and because we're interested in making sure that the data around the Hawaiian Islands is up to snuff, we're helping out with that. They just had their fancy heading device called a POS-MV. Their old POS-MV didn't work, so they've had a new POS-MV put in, and it isn't. It hasn't been calibrated yet, or if it has been calibrated, it's got a different value from what we're expecting. So it's going to be like this. It's what we're going to see, because I looked at this yesterday, is the effect of having the wrong rotation. So it's like it's like the gyro is off by a degree or something. So see how all these things are pointing off to one side? That's an indication of a heading error. And so I can tell right away, you know, they left port, it had been down for 2 months, and then all of a sudden I got this email that said, Hi'ialakai not logging. It's like, okay, they booted the computer, that's great. And then I got one that said, 4 good points out of, you know, a day or something. And I thought, well, I wonder what's going on. And then I thought, well, you know, I know they're going to Honolulu. Maybe I'll look and see whether there's actually any data yet. And I looked, and it's all pointing off to the side. So now I have to pay attention and get emails going and try to deal with making it look a little bit more sane. But it's a mixed blessing for me to have all these things on here, because it's like my little nursery of screaming kids. You know, sometimes they're all doing nap time, which is great, but there's almost always one of them with a toothache or a cold. But on the other hand, you know, they're out there being creative and making nice pictures, and it's fun to interact with all of the people involved. I interact with the company that makes the instrument, and I interact with the scientists who have questions about our software, or the acquisition software, what they can do with it. There are people who just want to look at the pictures and say, yeah, we crossed a front. They think this is great. There are other people who are more power users, and they have specific requests of what, you know, can we do such and such for them, or make something or other available for them. We don't take orders. We don't give people, you know, fries with that or whatever, but we do provide them with lots and lots of tools. So all of our software is available on the outside web, and if you're at sea with a Mac or a PC or a Linux machine, you can mount our software on a share, and you can do everything we do. And in fact, the same software, basically the same software that processes the data after this stage where you have a little profile, once they get stacked up and put into the database, and all of the post-processing software is the same software that we use on the commercial product as well. And so anybody who's out to sea who wanted to take our software with them and do this almost the same kind of live thing, at least on demand, it would be harder to make it be automated, but it's not that terrible to make it on demand. So ways that this have been used in a more power user sense include, for lowered ADCP processing, my responsibility on this cruise was to get the data and make sure that it was good, but the other people on the cruises, the way we happen to have divvied this up is that we're responsible for the shipboard ADCP final processing, but we all share the acquisition, and they're responsible for the lowered ADCP final processing.
So the people